Hello, and thank you very much for being here today. I'd also like to thank Inga Medows, our speaker for today. She's an extension plant pathologist with NC State University, and she's located at the Waynesville Research Station. So thank you very much, Inga. Take it away.
All right, thanks for watching today. Today I wanted to talk about some of the more difficult to control diseases of herbaceous ornamentals. And we'll kind of look at why they're difficult to control. So this is a slide from 2017 of the disease diagnostics that came through the plant disease and insect clinic at NC State. Granted, it's a couple years old, or a few years old now, but it generally doesn't change from year to year. And what I want to point out is that you'll see the water molds in that dark blue on the upper right of that pie chart represent 14% of our samples, our diagnostics. Bacteria, the next one down, the bacterial leaf spots or rots represent also 14%, and these two are the biggest chunk of our problem. So it's sort of representative of the problem in the industry and what nurseries and greenhouses have problems with. So I'll talk about those two, and the water molds are Phytophthora Pythium. We'll get to that. And then the other one I selected was Fusarium, because it's another wilt or crown rot, and it's down in the opposite corner of that pie chart at 5%. So within this, we'll also talk about Frack codes, and I'll start with that because it's one of the most important parts throughout the slideshow. And then I'll talk about some resources that are available for you. So what is a Frack code? Frack actually stands for Fungicide Resistance Action Committee, and you don't really need to know that. You'll just hear me talk about Frack codes. They have a website, frack.info. I have it on the top left-hand corner of the slide here. Essentially, the committee was established to manage and prevent fungicide resistance. So that's the whole goal. Frack codes are based on the activity of the active ingredient in the fungicide. So each frack code is specific to an activity. The table is updated annually, so it's a big committee that comes together and updates the table. They establish protocols for resistance management. And so every fungicide label has a frack code and it has resistance management built into there, all based on this committee. So what's the use to you? You'll understand more about resistance risk if you visit their website and or you look at the fungicide label, look at the risk management strategies, and then other general information is on there. This is the chart that is on their website. It's looks overwhelming at first, but one of the things you can find out is what the frack code is, which is on the far right side of that table. But you can also see in the column just to the left under comments which fungicides have a high risk, medium risk, or low risk to fungicide resistance. And they'll also mention certain genera of fungi that may be at higher risk for that particular fungicide. And then here's an example of a fungicide label that's got the frack code on it. Down in more of the text, you'll see more about fungicide resistance management. So that's just an example and a brief overview of frack codes. Not all products within a frack code are equal, so they don't all act the same. Even though they have the same frack code, it may not have equal control. And this just information that you'll have to seek from your extension specialist or your extension pathologist, one or the other. Resistance risk can be low, moderate, or high. As I mentioned, you can see that on the frack table. And certain organisms like botrytis are more likely to develop resistance to a given chemical and others are less likely. So you either learn this by experience or looking at that table, or again, learning from your agent or your extension pathologist. Fungicides with a single mode of action are more likely to select for fungicide resistance, but not always. So if you look through that frac table, you'll see differences. There are a lot of single mode of action fungicides, but they don't always mean that fungicide resistance risk is high. And then it's important to rotate those frac codes, of course, including those fungicides that are premixes, which what I mean by premix is that it has more than one fungicide or more than one frac code in that tank. Then the reason we rotate frac codes obviously is for minimizing or reducing that risk of fungicide resistance. And you'll see some letters in front of some of the frac codes. So you'll see M in front of some of them, and that means it has multiple modes of action versus a single mode of action. U is an unknown mode of action. Usually you'll see a U with products that are newer on the market. And then P means it has a host plant defense mechanism or induction. It's inducing the host plant to set up a defense. And these are less likely to develop fungicide resistance. Some of the newer fungicides, and they may not be quite as new anymore, but I've got a list here of several chemical fungicides, and then one biological here. The Botry Stop is a biological with a fungus as the active ingredient. So I've listed them here. I'm not going to walk you through them. It's just an example of some of the newer products that are out there and what they will manage as far as fungi. So let's move on to the bacterial leaf spots and blights. So generally these are caused by 3 genera. I have Xanthomonas, Pseudomonas, and Acidovorax listed there. You may have seen these. If you've had bacterial leaf spot diagnosed, you may have seen some of these names. Essentially, when we lump all the ornamentals together, there are so many different species of ornamentals that it's hard to single out any one crop. So I've tried to generalize here. The host range for bacteria in general is pretty big. The Xanthomonas species we generally see on geranium, ivy, ornamental kale, and I've listed a whole number of others there. Pseudomonas we generally see on gerbera, daisy, lavender, osteospermum, petunia, etc. Acidovorax we've seen on a couple species of plants. And species within each of these genera can be either host specific or have a wide host range. It just depends on the pathogen and the host. If you've had these diagnosed in the past, so Mike Munster, who's the diagnostician for ornamentals in the clinic, he generally can tell you if it's host specific or has a wide host range. But regardless, treatment is similar for all of these. I just wanted to mention a handful of them so you are familiar with or have an idea of what can be affected. Conditions that favor disease. So the Xanthomonas species, the ones listed at the top, tend to prefer really warm temperatures. The others can vary. So just because it may be cool out doesn't mean you won't see bacterial leaf spots. High humidity and water of any kind. So overhead watering, any standing water on those leaves can promote these bacterial leaf spots. So identification can be really tricky, and in general, it's not always easy to tell the difference between the bacterial leaf spots and fungal leaf spots. Even a pathologist can have a hard time telling the difference. But I have pointed out some tips here just to sort of help you navigate. And not all of these symptoms may occur. So you may only see one or a couple of them. So generally the small circular spots might be bacteria. The center of that spot may fall out, so it looks like a shot hole appearance. And these symptoms may be specific to a certain bacterial pathogen on a specific host. You might see water soaking, which is on the picture on the right-hand side, on the underside of those leaves, you see sort of darkened spot areas that look, some people call it greasy looking. That's the water soaking. And generally you'll see this on the underside of the leaf in the morning or just after watering. Sometimes the lesions start at the leaf margins. So like on the picture on the right, you'll see most of the damage is starting at the leaf margin and working its way inward. Sometimes you'll see a yellow halo around the lesion. You might also see more in areas where water accumulates, like at the leaf tips. Bacterial streaming is one of the relatively easy diagnostics that we use. If you have a stereoscope or some kind of basic microscope, you can do this yourself, and I'll show you a picture of what I mean by this, but not everyone can do this. So essentially, diagnosis needs to be confirmed in the plant disease and insect clinic. So I'll show you some examples. Here is Xanthomonas on zinnia. You'll see on the bottom left, the circular picture there, you see the yellow halo or light greenish halo around those spots. And on the bottom right, you see sort of a close-up of some water soaking. Those darkened areas are the water soaking. This is Xanthomonas, a different species on Geranium. This is probably a better picture of the water soaking. So you'll see early stages of water soaking on the leaf on the left, those dark green areas. And then as the disease progresses, it turns into a more darker area, as in the leaf on the right. This one, if we were in person, I'd ask you to guess which picture was bacterial and which picture was fungal. Since we're not in person, I'll give you a clue. The one on your left is actually Pseudomonas. It's a bacterial disease. And the one on the right is actually a fungal disease. And the problem is they're not always easy to tell apart. And I think these pictures demonstrate that it's not easy to tell. This is a picture of bacterial streaming. So you'll see the green arrows on the top part are pointing to the bacteria that's actually streaming out of this leaf tissue. It's streaming out of the veins. This is under a microscope at 30x magnification. So you can't necessarily see it with your naked eye, but under the microscope you can. If someone were to try to do this themselves, which is totally fine, just keep in mind that sometimes the light reflections, like I've shown at the bottom, sometimes look like bacterial streaming. So just keep that in mind. All right. So management for bacterial leaf spots. This really requires strict sanitation. We don't have good chemical controls for managing bacterial spots. So it's all the cultural practices ahead of time before you go to a chemical control. It's really important to sanitize tools using clean soil and pots and disposing of any soil or plant debris. And then if you do see bacterial spot in your crop, removing those affected plants plus the adjacent plants. A lot of times the bacteria has already spread to adjacent healthy looking plants. They're just not showing symptoms yet. So you may be doing yourself a favor to get rid of those asymptomatic plants that are next to the symptomatic ones. Avoid overhead water as much as possible. Obviously, that's not always possible. So if you do need to overhead water, do it when the foliage can dry quickly, usually in the morning. Heating from underneath helps dry the foliage quick. Again, that's not always possible, but it helps if you can. Avoiding handling plants when wet. So it's not a good idea to move plants right after you've watered them. Try to move them when they're dry and then water if you need to. And I always put using preventative sprays as the last step because it should be the last step. All the other cultural practices I mentioned should come first. So copper and strep, I have a list on the next page, but copper and streptomycin are the most common, but resistance can occur in these pathogens to copper and or streptomycin. Once plants are infected, chemical control is not effective at all. So again, it's removing those affected and adjacent trays, and then you can treat the remaining healthy plants. So just to reemphasize, the IPM strategy must be employed for effective control. So I've listed a number of products here that are labeled for controlling bacterial spot. I've put efficacy on the far right, and P stands for poor, F stands for fair, and you'll notice I don't have a G or an E, which would be good or excellent. So it's clear we don't have good chemical controls for managing these things. I've got a little R next to the products where we've seen resistance. And if you do send in a sample with bacterial leaf spot to the clinic, they can evaluate for resistance to copper or strep. Right now, they're not doing it because they're only in there 2 days a week. But when we do return to normal hours, they can evaluate for resistance. And I've got a star or an asterisk next to the ones that are OMRI approved or where they have OMRI options available. Okay, so I'm going to move into the Fusarium wilts and crown rots. And just to help define what I'm talking about, there is a difference between wilt and crown rot. So a wilt technically affects the vascular tissue. And this is where you might see discolored streaks when you slice open the crown or the lower stem. As I've gotten the picture on the bottom right, this is actually a tomato stem, but it's similar to all our other crops where Fusarium wilt can occur. So you'll see the discolored tannish or light brown area. That's the actual vascular system that's discolored. Versus a crown rot just attacks the crown of the plant. And the crown, when I say crown, I mean the crown is the base of the plant right at the soil line. There you would not see streaks past the rotted crown. So different species and or Forma specialis can cause Fusarium wilts and crown rots. It depends on the host. Forma specialis, all that means is it's a strain of that species that is specific to a given host. So some common hosts include Hosta, Chrysanthemum, Osteospermum, Pinks, Liriope, and there are a number of others. These are just probably the most common ones we see in the clinic. Symptoms, again, it depends on the pathogen and the host, but you might see a one-sided wilt, whereas one side of the plant is wilting. You might see yellowing or tan leaves. If you cut open the stem or the crown, you might see a dry rot, or you might see discolored vascular tissue, as I mentioned before. So I'll show you some pictures. This is Fusarium wilt on dianthus. Here you can see the yellowing on the leaves, especially on the leaf tips. So it might look like the plant has dried down, but really it's a Fusarium wilt. This is Fusarium Crown Rot on Liriope. Again, you see the yellowed or tanned leaves. And if you were to take a look at the crown, this one causes crown rot. You can see in the bottom left picture the rotted leaves and crown there. This is Fusarium Crown Rot on Hosta. So again, you see those tan colored leaves. And if you were to slice open the crown there, like in the bottom right, you would see sort of a dry rot right at the crown. On the left, I have the characteristic picture of the characteristic spores. They're generally canoe-shaped and nothing else really looks like these spores. This is, of course, under a microscope. But essentially, the management is made difficult because the spores are easily spread by water splash, so they can splash to adjacent plants when they're watered. And then infested soil and plant material can also serve as a means for transmitting the fungus. They also have survival structures. We call them chlamydospores, but they're just a different type of spore that can survive in soil for long periods of time. And then fungicides, we can use fungicides, but they're difficult to get into the soil and the roots before disease occur. And you have to consistently reapply if that fungus is present in the soil. So management, again, it's a lot of cultural practices, inspecting planting material when you get it, getting rid of that the poor quality planting material, disposing affected plants and adjacent plants. Again, as I mentioned, you know, the spores can be spread by water splash. So it really helps if you can get rid of affected plants and assume that the adjacent plants already have the fungus, and to get rid of those as well. And disposal should be away from any production area. And this goes for other pathogens and diseases as well. Avoid reusing pots. So, you know, once you've discarded those plants, I've heard of people reusing those pots. Well, that's just going to spread the disease to your new healthy plants. So avoid reusing those. If you do have to reuse them, rinse them thoroughly, get rid of that crop debris and soil, and then use a sanitizer. And I've got a list of sanitizers at the end and where you can find it online. Scout frequently. It's easier to manage a disease when you catch it early rather than wait until it's progressed and it's unmanageable. If you do have a history of Fusarium, it's good to use fungicides preventatively. We don't have any curative fungicides, so if you've got affected plants, the fungicides will not help. So I've got a list here. There are actually a number of fungicides registered for Fusarium Control. I've got thiophanate methyl listed there, iprodion, of course, there are various products there, and I've got the Frack Code and the Efficacy listed there as well. Products that contain the strobiurine fungicides, and examples would be azoxystrobin, pyraclostrobin, trifloxystrobin. I've listed some examples there. Same with fludeoxonil and the Frack 3, the metconazole, and those products that either are that active ingredient alone or have that active ingredient in a premix should be effective. Again, it's important to rotate those Frack codes. Do not use the same Frack code continuously. Essentially, this is on the label, and it's good to apply as a drench or as a directed spray and early on in your plant production. So let's move on to the Phytophthora root rot and stem blights. And Pythium root rots. So these we generally call water molds because they prefer wet or poorly drained areas, puddles, any standing water, or saturated soil. There's a large host range because there's so many species of Phytophthora and Pythium. There's a number of different ornamentals that are affected. I've listed some examples there, but there are more. There are multiple species of Phytophthora and Pythium. Some species are host specific and others are not. So it just depends, again, on your pathogen and your host. Survival structures allow these guys to survive for years in soil and plant debris, and it's one of the things that makes management difficult. They're easily spread by water. So again, water splash or even standing water, infested soil and equipment, and infected plants easily spread these diseases. The bottom right, I've got sort of a diagram of a life cycle of a basic Phytophthora, but essentially those structures are what make it easy to survive and spread. So those oospores and chlamydospores are two structures that can survive long periods of time. And then the sporangia and zoospores in the top bit of that picture are the structures that can form and spread in water. Identification in the field can be tricky because there's a variety of symptoms and they can often be mistaken for other diseases. And again, depending on the host, they might cause a root rot, a collar rot, or some of them cause an aerial blight, which is a little bit different for the water molds. You may see a wilting, you may see water-soaked lesions, and again, you see that water-soaked term. That one, obviously, also bacteria can form these water-soaked lesions, so it's important to be able to tell the difference. Lack of roots or discolored roots is another symptom. Stunting, especially Pythiums, can cause stunting, but Phytophthora can as well. In general, I would say the Phytophthora are more aggressive, and the Pythiums tend to sort of nibble on roots, resulting in stunted plants, but again, it's not totally specific. Pythium can also be a damping off pathogen, and damping off is when you have seedlings that emerge, seeds that germinate and emerge and then fall over or collapse due to Pythium or a number of other damping off pathogens. You may be able to tell based on the disease pattern. So if you see higher disease pressure in depressions or wetter areas, you may suspect Phytophthora or Pythium. If you have Agdia test kits for Phytophthora, these are a good way to tell, a good quick 5-minute way to tell if you have Phytophthora. They're expensive. You can get them from agdia.com, and I've got a picture of them there on the right-hand side where you see the bottom strip is a negative reaction and the top strip is a positive reaction. They're a little bit expensive, but they're very quick, 5 minutes, and anyone can do them. Otherwise, it's best to get a disease confirmation from the plant disease and insect clinic before you start considering any treatments. So just some pictures or example pictures here. This is Phytophthora on annual vinca. Annual vinca is one of those oddballs that gets Phytophthora Phytophthora causes a leaf blight on annual vinca versus a root or crown rot. So that one's a bit of an oddball, but it's very common on annual vinca. Phytophthora on spathiphyllum, this causes a root rot. You can see the discolored roots there at the bottom of the picture. There's also a lesion spreading up the leaf that you'll see sort of in the top right of the picture, but generally it's a root rot symptom. And Phytophthora on daylily, so again, the above ground symptoms, you get those yellowing leaves or stunted or plants that aren't growing well. And then when you pull up the plant, you see the roots down there are very discolored or lacking. Phytophthora on Calibrachoa. This is similar to petunia, of course. You'll see a lack of roots down there, and the roots you do see have some discoloration on them. And then you see the above ground wilting. This is Pythium on petunia. So the petunia on the left-hand side is healthy. The one on the right obviously has Pythium, lack of roots, and you can't see the above ground parts, but the one on the right is stunted. And obviously this is basil, but it was a good picture to demonstrate the stunting that Pythium can cause. And you can see it in sort of a random pattern or pockets in this planting. And then if you pull one of those stunted plants up, you see it has very little roots, and what roots it does have are discolored. So management, again, you're going to hear me say this, sanitation, using clean pots and media, equipment, cleaning benches after production, especially transplant production areas. If you do reuse pots, of course, rinse and get rid of that crop debris and soil, and then use a sanitizer. Avoid overwatering and avoid poor drainage. Those two things will really promote Phytophthora and Pythium. Again, roguing affected plants and adjacent plants, because the spores have probably already splashed onto your adjacent plants. And again, disposing of affected plants away from your production area. It's best if you can keep plants off the floor, and this is not just for Phytophthora and Pythium, but for other diseases. And people often ask, well, how high do I need to keep them off the floor? High enough to avoid water splash, probably a foot or two at least. And I know that's not possible, but the floor is where a lot of soil and crop debris can hang out. Find the source. It's a good idea with any of these to try to figure out where it's coming from. How is your media being stored? Is it coming in contact with old pots or water runoff or outside soil? Are you reusing the pots? And if you are you cleaning them thoroughly? Do you screen germplasm? And so on. And again, the fungicides are preventative only. We don't have curative ones for these Phytophthora and Pythiums, and you have to use them early, and you also have to reapply for them to be effective. So I've got a number of them listed here. I've got the Frack Code and Efficacy, and again, efficacy can be quite variable depending on when you use them and how heavy your disease pressure is. I've got a note at the bottom. Resistance has been seen in Pythium and some Pythiums and some Phytoptheras to mefenoxam. So be aware of that. Also, some Pythiums are insensitive to the Segovis product. So it's a good idea to A, rotate, and B, understand what's working and what's not in your rotation. I want to move on to talking about some resources that are available to you. The Southeastern Pest Control Guide is a really good guide. It's free online, and I believe it's $20 to purchase. Don't quote me on that number. It's from 2017, so there are a few more products available, but it's still a good resource to use. The NC Ag Chem Manual, I've got the 2017 version up there, but of course the 2020 version is out. Again, it's free online, but if you want it in hand, it's $35 purchase, but it's really helpful for weed, insect, and disease control. It's also got PGRs and fertilizers in there, so it's a really good resource. My team has been doing updating some disease fact sheets and recommendations, and I've got a list of 3 of them there that are up and ready to go. Lots of good pictures and hopefully some helpful diagnostic tips. So those are available online. And then another good resource, if you're wanting to look at efficacy of products, not just fungicides, but also insecticides, herbicides, and so on. IR4 project is a USDA funded project, and their whole mission is to get pesticides registered for minor use crops, and that includes ornamentals. So the top bit is just a picture of their homepage. But then if you were to search in their website, you can search for research summaries and find crop safety and also efficacy studies for, again, entomology, pathology, and weed science. So it's a really good resource for growers and for agents. As I said before, I was going to show you a sanitation table. So this is online. If you were just to Google treatments used for sanitizing tools and equipment, this table should come up. It's a PDF. You can easily print it as a one-page. Just has a lot of good information on sanitizers and how to use them. Some other resources. I've mentioned the Plant Disease and Insect Clinic multiple times. Good place to get your plants diagnosed. The NC Department of Agriculture will do soil and tissue testing, and will test for nematodes if you suspect you have a nematode problem. NCSU Pest Alerts and Pest News, it's a good idea to sign up for those. If you just Google NCSU Pest Alerts or Pest News, you can click on one of the alerts, and then in the bottom right, you'll see a space where you can put in your email, and you'll get these alerts and news once a week. The sanitizers is also in the Ag Chem manual. So if you can't get to it online, it's in that manual. And with that, I'd like to thank you. I've put my contact information down at the bottom, and I hope this was helpful, and thanks for listening.